Welcome to section 2.2 over direct variation for Algebra 2. Now here's an oldie but a goodie math joke. Why was 6 afraid of 7? Because 7 ate 9. Let's start by defining direct variation. Direct variation shows a direct relation between two variables. So think about some things that you have experienced that have a direct relation. For instance, one of those things might be the number of hours you work to the total pay you receive. There's a correspondence there. Or maybe another thing is the number of miles driven with the amount of time spent driving. So the more time you spend driving, the more miles you drive. There's a direct relation there. Okay, direct variation is going to be in the form y equals kx. And k is known as a constant of variation. Now sometimes you might just want to know what is a constant of variation. So you need to solve this equation for k. So if I divide both sides by x, k is going to be the relation between y over x. Okay, let's go ahead and practice. Example 1, problem A, says for each function, determine whether y varies directly with x. What that means is we want to know, are these going to be in the form y equals k times x? And if it is, you want to find the constant rate of variation, which means find k. Then you need to write the function rule and then graph the function. Now the graphing of the function I want you to do on your own. Okay, so to see if these are varying directly, if y varies directly with x, we need to look and compare. Because if I compare each of the points, they should have the same k value. If they have the same k value, then it's a direct relation. So to find the k, you may remember you simply take y divided by x. So that's what I'm going to do here. What is 2 divided by 1? And of course we get 2. Then I do the next set. 6 divided by 3, you should get 2. Finally, 8 divided by 4, you also get 2. So they have the same rate of variation, which is our k. So I need to write k equals 2. Then it tells me to go ahead and write the function rule. And the rule is going to look like y equals 2 times x. When you write the function rule, you simply take your k value and you plug it into your function. X and y should be left as x and y. Alright, so these may look familiar to you as a linear equation. Alright, let's go on to B. We're going to do the same thing here. You need to compare y to x and see if each set of points has the same constant. So when I take 5 divided by 2, I get 2.5. And you can just use your calculator. When I take 7 divided by 3, I get a number that's not 2.5. It is 2 1/3. So right away I can stop at these first 2 points because they do not have the same k value. So all I need to know is these are not constant, or they do not vary directly. No direct variation. Okay, for problem C, I want you to ignore that one. And then I want you to go ahead and do D on your own. Example 2 is very similar to example 1. It says given y varies directly with x. So just from this statement, we know that they should have the form y equals k times x. when y is 27 when x is 6. We want to write the direct variation function. Well, remember, to write the function, you need to know the k value. How do I find the k value? If you remember, you simply need to divide y by x. So in this case, all I have to do is take 27 divided by 6. And that is going to give me 4.5. So my function is going to look like y equals 4.5 x. Okay, problem number 3 puts a little twist on it. Again, we know that y is going to vary directly with x. So they're going to be in the form y equals k times x. But this time we say y is 15 when x is 3. What is y when x is 121? Well, because they vary directly, these numbers, when y is 15 when x is 3, think about that chart. If I put my x numbers here, my y numbers here, okay, we want to know what is y when x is 121. Well, they would have to have the same k value, like I said, which means I can write them as a proportion. To find k, we simply take, again, y divided by x. So that's what I'm going to do. I have 15 divided by 3. And then I'm going to do the same thing for when x is 121. And I want to know, what is my y value? So I set up my proportion, and I need to cross multiply. I have 3 times y, and that's going to be the same result as 15 times 121. 15 times 121 is 1,815. Divided by 3, and you get 605. So that is my answer. And you can check. When x is 3, or y is 15 when x is 3, that's a constant of 5, a k value of 5. And for the next set of points, it should also be 5. Is 605 divided by 121 5? Yes, it is. So I know I've solved it correctly. Okay, for the rest of the problem, you need to go ahead and do number 4, and then see if you can try to do number 5 as well.